My name is Gulnara. I've been working as a data scientist in grid dynamics almost 2 years. And before coming to data science, I worked as a scientific researcher in Central Psychoeconomic Research. And in many things, it's determined what I'm currently doing. The projects in which I participate lie in the field of programmatic marketing. This is solving problems related to consumer behavior and the automation of different marketing processes. And all that I will talk about is connected with this area of programmatic marketing. Especially, I will talk about a little about what programmatic marketing is and what task it solves, and do more detail on a very large task, which directly or indirectly lies in the basis of construction solution, most often the demand prediction task. We'll consider how this problem is solved analytically, how machine learning solution is traditionally built, what consumer data can we use when building the model, how to measure the quality of the resulting model, and what solutions can be used to improve the business efficiency of the model. So, what programmatic marketing is? Often this area is associated with advertising, automatic targeting, selection of numbers of ad runnings and something like that. We consider this area much more wider. In modern world, in addition to advertising targeting, the following tasks are automated pricing, when prices dynamically change during the day depending on the large number of factors. Promotions are targeted, personal discounts are determined. Another part is inventory management. It's automation of logistics processes, ordering products for future periods. Automation of products recommendation based on your preferences and preferences of people who are similar to you on any ground. And prediction of promotions and advertising campaigns performance. And this is not the whole list of tasks, but the area I think is clearly drawn. Most of the stated problems are directly or indirectly solved through the task of demand prediction. If you want to determine the effectiveness of stock, most likely you will determine how many products will be bought for this stock, how many products you have to hold in the stock to reduce the holding cost. To evaluate some advertising campaign performance before it starts, you need to predict how many products will be sold. If you are going to make discounts on certain products, you will evaluate how much demand will grow. Sorry, I have problems with my touchpad. So therefore, I decided to focus on what could be more important than numbers for solving this problem. How this problem is usually solved analytically. To deal with this, we will have to go from the economic angle. Therefore, let's have a minute of economic theory. Economics studies the system as a whole, a system of relations arising from production, exchange, distribution, and consumption of goods. During 5 years of my studying at university, this definition was pounded into my mind. So if you wake me up at night, I will tell you the subject of economics with no opening my eyes. There is no single person in economy. There are no personal preferences, interests, or attitudes. In addition, economics is not a very accurate science. It is based on less than 20 laws. I specifically checked before this talk whether something has changed. Everything remains the same. One of the main laws, and probably the most famous economic law today, is the law of supply and demand. Oh, I'm so sorry. How it sounds? Holding else equal, lowering the price of a product and lowering the price of a product increases demand willingness to buy and reduces supply willingness to pay. Ideal situation for forecasting demand, isn't it? We need only one factor, the price of goods. The price doesn't change, demand remains constant. If we make the discount, demand increases. The way how strongly a change in demand responds to a change in price is called elasticity of demand. Different categories of products may have different elasticities. For some products, this curve will turn into vertical line. For example, for essential goods, demand will be constant regardless of price changes. For some products, the rate of decline of the curve will be higher. For some products, lower. Perfect picture, isn't it? Why we need machine learning here? We just need to calculate the elasticity coefficient for each product and place it into the formula. And bingo, you are great, you could predict demand. But unfortunately, it doesn't work in real life. Why? There are a lot of reasons. First of all, goods are very heterogeneous in terms of distribution of the elasticity of each product. I'm talking not only about products of separate categories, for example, food or clothes, but even elasticity of products with different size and color can vary. Elasticity varies from time point to time point. A lot depends on what kind of product grouping you are doing, and it is necessary to group products correctly. This approach has very low prediction accuracy. But the main problem is in the most important part of the supply and demand law formulation that everyone always forget. Holding all else equal. However, there can be multitude factors that influence demand. In turn, machine learning approach allows us to take into account a lot of necessary factors. So how traditional machine learning solution scheme look like? First of all, everything starts with data. If we look at the data from analytical or statistical point of view, only one interesting thing here is demand itself, its trend, seasonality, and etc. However, a lot of information remains outside our field of vision. Here is a small example, but when you look at the data, at real data, you can find a lot of interesting things there. We observe what data we have and what target we have to predict. If we approach the problem from statistical point of view, I could say again, we need only demand itself and analyze its trend. But in this case, we will miss a lot of important information that influence the fact of purchasing. For example, age, gender, purchasing history could help you to find product that could be interesting for such kind of customers. So we determine what data we need, whether this data is suitable for the method that have chosen, and in what form they should be transmitted to our model. We determine how we will evaluate the effectiveness of the prediction of our model and what should we optimize for learning. And in my speech, I would like to focus on these things. The only thing I want to say about the model itself, that I will talk about the type of models in which correctly selected parameters or features have a great influence. I have already participated in several projects directly or indirectly aimed to predicting demand, consulted with colleagues, and at the moment, such algorithms as gradient boosting, sometimes random forests, in the case when there is no enough data, good feature engineering, I repeat, in solving of the forecasting demand prediction problem, perform better than neural networks, which doesn't require meaningful data processing. So let's start with the data. What information is helpful and useful to use in the demand prediction problem? what insights could we find in external signals, social environment, and even human behavior patterns. I divided the data into 3 large areas. There are economic factors, social factors, and psychological factors. Let's consider each sphere in more detail. First big group is economic factors. The first is, of course, as we said above, price factors. Changes in the price of goods, discounts, seasonal changes, new products, price of competitors as an example. I read a funny research about selling a keychain with a minion on the Amazon website and took competing large stores. Someone, just to satisfy his interest, conducted a study of price changes. He monitored prices for 6 days and found that the price for 6 days changed 101 times. It fell to a certain level, rose to the original level, and fell again. In such a way, all 3 sites have different prices at the same time. Obviously, there is a monitoring of prices even for such small product. The following factors are product factors. Products are different, therefore their demand can be different, which must be taken into account. So, for example, if we return to the theory, there is a grouping of ABC products. A group is a group of products that provides 80% of sales or profit. Usually it's 15-20% of all products. B group provides 15% of sales or profit. Usually it's 35-20% of all products that are selling in store. And C group provides only 5% of sales, and usually it's 50-60% of all products. Another one grouping is competitive and substitute products. Products could be luxury and essentials. Returning to elasticity of the products, we can assume that the more expensive products and every day the cheapest products have less elasticity. Also, we could use macroeconomic factors too. This may include the general level of purchasing power, the exchange rate, and percentage that's spent on saving. All this information can be collected from the open sources. For example, in Russia, this information is collected by the government statistics department and regularly updated and stored on their website in public domain. So what features we could use? We could use product categories, price attributes, sales plan, prices of competitors, macroeconomic factors that represents the purchasing power in specific area. Next big group is social factors. Social factors are associated with interaction with people around, the so-called reference groups. I will not go very deep into it because it will strongly depend on category of goods that are sold and the demand of which is need to predict. This includes consumers that belong to particular subculture, social class, fashion trend. Belonging to the social class is closely related to economic factors. It can be probabilistically assessed again from the open statistics sources by income level. And fashion trends are often set by the manufacturers of goods and retailers themselves. And we can assume a surge in the demand for the new collections, social trends, and advertising. So here we could use social class product affiliating and fashion trends. Next group is psychological factors. We have already talked that in classical economic theory, there is no individual person with his preferences. It proceeds from the fact that we are all rational. That means that we always know what alternatives we have, how to distinguish a bad product from a good one, and we always choose the best. This is not due to the fact that scientists really think so. It is assumption and simplification of reality that they are making to explain the processes that taking place in the world. In fact, this is far from real life, and economics turned its head toward individuals, and it appeared the whole direction at the intersection of economics and psychology, which studies the consumer decision making. On this slide, it is shown the classical diagram of how decision-making process is going. I will dwell into on the first three stages in more detail, tell what it means and what data we can use on this basis. First three is most important for us because it precedes the purchasing stage. The first stage is needs recognition. This is moment when you discover that you need to buy something. For example, the current situation, there have been large changes in the ruble exchange rate, and prices for household appliances will increase objectively. Knowing the average level of wages in the region or country, as well as distribution of income, you can adjust the demand. People are waiting for a jump in prices, and such expectations will sooner lead to an increase in demand than the actual price decreasing. The second stage is search. People search necessary products to purchase using different behavioral patterns that could be grouped. Knowing to what group the customer belongs, you could determine if it is needed to make an offer for him to help him with choice to push him or her to purchase, on not to spend money on the offer because the customer will buy something in your store anyway. There are four main types of customers. First type is direct consumers. They visit the website with the intention to purchase a particular product. They rarely leave the website without having any purchases. And usually the time sessions, time that they are spent of viewing different products is rather short. Second group is consumers who search. They generally intend to buy a product from a certain category. It is possible that they make their purchase after several visits and comparison with other websites and shops. Third group is hedonic browsers. Initially, they do not intend to purchase any product at all. And if they make any purchase, it's just the result of stimulus from the website. The last one is informational gathering visitors. They visit websites to gather information without any intention to buy. These types we could determine from the activity on web store and length of session. However, simply measuring of session length is not enough. Depending on which product is selected, in which category it belongs, the customer will need different time to make a decision. If you choose something that has a short lifetime and is not expensive, like some clothes, you will need less time to make decisions than if you choose something expensive and with a long lifetime. The next step is a comparison of alternatives. A huge number of factors can influence here, down to the way information is presented. Customer loyalty to a particular brand, his tendency to impulsive purchases, or regularly recurring patterns of behavior. Also, even ways of presenting information, place of ad on the page, using colors, or some price tricks, like on the slide, are important. For example, I think everybody knows that reducing price on 1 cent, for example, make price $2.99 instead of $3.00, gives the impression of lower price. But if we talk about prices that have neither 99 cents nor zero at the end, there is a different situation. Even the number of syllables and number play a role. If you have longer word, your impression will be that the price is higher. Another example is comma separation. a price without a comma looks cheaper. So as features, we could use customer information, clickstream data, purchasing history that shows customers' behavioral patterns, types of information presenting, customer grouping on the basis of session lengths, cart value, customers' reviews. In total, we have a huge amount of useful information that can be obtained by analyzing of user behavior in Web Store, open statistical sources, analysis of competitors, advertising and methods of providing information about a product that affects demand, and that can be used in the forecasting it. But of course, the area is not limited by these factors. In one of the projects for a major online retailer, an important role was played by the weather. Our demand forecast model had the best performance when we added weather conditions as a parameter. It turned out that people prefer to buy online when it rains outside. This graph shows two metrics for assessing the predictive ability of the model, R-squared and mean absolute error. They are often used to for evaluation of regression models, to which demand prediction refers. If someone is not familiar, I will explain what does it mean. Mean absolute error is how much the predicted data on average differs from the actual ones, and R-squared score shows how much better our model works than if we use an average prediction. In addition to them, there are other metrics that all evaluate how much the model mistaken from its forecast. And here we move to the next very important part. What metrics should be used? How to choose the indicator that shows on the best is our model good or not? We remember that we are solving the problem in the field of programmatic marketing. Imagine that we have a new account that is interested in data science research. What do you think is the main question that will interest him? How does it help to earn money? And if our account is one of the famous companies that is usually accounts of Great Dynamics, how does it help to earn more money? Or what can you offer that will work better than a team of financial, analytical, and marketing departments? If you say that your model have a good R-squared score, they are unlikely to be satisfied with this answer. And it also happens that R-squared is not very good. There on the previous slide with the weather example, it was 0.4, which is rather low indicator of model efficiency. I'll tell you a story that happened on a project on which we worked with our colleagues. The case was following. The marketing department of a large retail company made a decision on whether to conduct a discount campaign based on the results of the previous 3 weeks. The task was to predict the demand for the 4th week and note which campaign, according to our estimates, would not be profitable. We went deep into data. We built a model for predicting the demand and began to evaluate its effectiveness using R-squared, and it was 0.4. We began to look for the reason and found that we have a very large standard deviation in our data. We tried to choose a metric that is insensitive to outliers. Without considering the essence of processes, this didn't give us anything. You just get the numbers and it doesn't tell anything to you. On the next step, we made a really good job. good in terms of the fact that we began to move towards the essence of things. We decided to see which metrics are correlated with business metrics. How this happened, we took the principle of cross-validation, broke the data into 5 folds, and looked at the changes in statistical metric and business parameters. As a result, when we turn the task to the profit level, it turns out that we predict unprofitable campaign very accurately, despite the actual value of the metric. I'm saying things that are probably obvious to someone, but I would not talk about them if we hadn't spent almost more than a month for research to solve this problem. That was not a problem at all. The metric should always be measurable in the business terms, but not only the metrics. What should be optimized? I'll tell you some examples how we used business indicators as a target objective function in training. One example is optimization of the numbers of booked and offered products for sale or safety stock prediction. Case was the following. For a company that uses program buy online, pick up from store to attract customers. The idea of this program is that you can book the product online and get it in the nearest offline store, or order the delivery from the nearest offline store. In such cases, there should be some reserve in offline stores that will be held in the store, but will not be available for online customers to purchase. If the stock will be very high, there will be a concern that the company could lose the profit from possible online sales. If stock is low, the company holds reputational risks because it should be the situation when somebody will book the product that will be sold while booking, and it will increase delivery time significantly. To balance these risks, we used custom objective function, symmetric mean square error, and changing the coefficient of this metric, we could choose what is more important for us, to lose profit from offline sales or reputational risks. We went further and made the custom objective function for light GBM, in which you can specify that we need more goods in store or more goods in storage. Another case we worked with is related to increasing the direct probability of a discount campaign. There is a campaign in which the discount is static and constant. The customer wanted personalization of discount. The task was to predict demand at a different level of discounts, choose a combination of discount that gives maximum profit. How did we solve it? We put in the model 2 optimized parameters of revenue and profit, which are the main indicators of the campaign for the customers. Moreover, 2 options are possible. You can fix the profit so that it doesn't become smaller while increasing revenue, and you can fix the revenue to increase the profit. Solving data science problems, first of all, we are solving business problems, and it is necessary to think about business metrics as a major quality measure of your model. With my talk, I wanted to draw attention to things that often remains outside the field of vision of people who are called upon to solve problems from a technical point of view. However, if you work in the field of programmatic marketing, you need to remember that often the right data selection can give more than complexity of the model. That metrics should always obey in business goals. Do not forget about the subject area, because many interesting things are hidden in it. There is always a real process behind the modeling. And when you're going deep into numbers, the main thing that you should remember is the purpose of building a model. And first of all, what business tasks should be solved. Thank you for your attention. I will be glad to answer your questions.
Thank you, Gulnara. So then I'm happy to pass microphone to Stanislav Stolpovskiy, at Grid Dynamics architect, and he will be the second speaker of our meetup. So Stanislav, let's go ahead.
Thank you. Hello, everyone. Let me share my screen and I will start. Hello, everyone. So my name is Stanislav Stolpovskiy. I'm a search and ML architect in Grid Dynamics. Today I want to talk about delivering ML into production, how to build the robust pipelines, how to organize the work of data science team and collaboration with DevOps team to divide responsibilities and to make this process much faster and more efficient. Just a few words about myself. I'm working in IT for the last 15 years, joined Grid Dynamics in 2015 and working for search for 9 years. Last 5 years, I specialized in ML and deep learning. I did a lot of projects for big retailers in the top 100 companies in US, build a few search platforms, and like to build small robots in my spare time. So let's get started. So we have pretty strict goal. We have ML model or deep learning model, and you have your data science team which construct this model, and their plan is pretty clear. They spend a lot of time on creating the proper model, defining levels, setting the subdata, train the model, and then they done. They did their job and they can work on another project. But the thing is, in reality, the problem is only beginning when your model is trained. You have to move your model into production. You have to get stable response time. You have to stop all infrastructures. And here's the things come up. Every time, for every project, you need to do it from scratch because there is no common patterns, and data science team usually have no idea how general, not everybody, but in general, how web service is created, what is the cloud, how the infrastructure looks like, and you need to deal with them over and over again. Maybe some experienced engineers can do this, but in general, it always starts from the beginning. So they're happening for a long time, but now there are lots of tools that make these things much easier, and I want to talk about a few of them. First of all, let's start from our goal. Our goal is to define process of building this pipeline into 3 big steps. One will be all actions related to data and training. The second big step will be saving this model in a format which it can be used as a straightforward deployment unit. And third step will be deployment into your cloud or premium cloud or any cloud providers like Amazon, Azure, Google Cloud, any. And we're defining these 3 big steps, and each steps we will describe and see how we can define it. So general data science team working with different frameworks. It can be TensorFlow, PyTorch, it can be a set of tools from classical machine learning like XGBoost, linear models, Sparks, all of that. And they need to come up with some common template where they can run any framework and any code using the same approach. After that, these different types of model needs to be saved in the unified format, which helps to make this process much easier. Here comes description for MLflow model registry, which I'll be talking about, which unified and store all models and provide the versioning for them. And after we have models saved as in unified format, we have a process of retrieving this model with particular version and deploy it into our prepared cluster. We will be working with Kubernetes, and Kubeflow on top of that for deployment. So let's get started. So we will be talking about three main components today. The first one is well known. It's a Jenkins CI/CD platform. I will not spend too much time on it, but it's one of the core components to tie everything together. It helps us to optimize routine stuff for containers build, for pipelines upload, for Git pull requests, and all that stuff. So all the things that you do with your scripts or you do manually can be automated with Jenkins and needs to be automated because it's saving a lot of time. The second big component will be Kubeflow. Kubeflow is a ML platform on top of the Kubernetes, which allow you to create pipelines and help you to run your jobs, help you to run your deployments, make it all working. And the third component, which is obvious, but I'm a bigger fan of it, is the ML flow. ML flow is kind of doing the same stuff with Kubeflow is doing in scope of tracking experiments, tracking metrics, but it provides pretty unique model registry, would help you to get your models up to date, to get your proper versioning, to understand what was before and tied to experiments to actual GitHub code. It helps to provide very reproducible results and make these things more clear and more stable. Let's start from this ML flow. The ML flow consists of the three big components. It's MLflow project systems, which help you to standardize the input into your training. You can define ML project file in your GitHub project, define how your model will be run inside this file, and send it to next execution. Next unit, which get your code, already know how to run it. It will be simple MLflow run command, which run any code, and you don't need to find which file you need to run. You don't need to understand the code. It's always the same entry point. And because you created this configuration before, it's always a standardized way to start your training. The second big chunk inside this MLflow project is using code environment. You can define your code environment, and this environment will be created for this exact run. It will be created from scratch. It's similar to virtual environment, but it's have more version control, and it's provided installation for additional libraries on top of the system, which helps you to make your project working on every container and every subsystem, make it more robust. The second big part of MLflow is a MLflow tracking UI. It helps you to compare different runs, track metrics, track parameters which was used to run this experiment, and it helps you to track back your GitHub commits. So you can always understand which snapshot of your code was executed at which point, which parameters was used, and which results we provided for this run. Also, this run can store artifacts, so you can have your train model saved and be stored and tied with a particular exact run of execution. It's help you to bring your training in place, it help you to bring order in place. And if you have situation when some of your data science team work alone for some project and then left the company or get sick or get transferred to another important project and you need to take over him after a year or two, you have all information you need to reproduce his experiments to get the same results as he did 2 years ago. That helps a lot. In my practice, we using MLflow a lot, and this tracking is very helpful. And the third big component inside this ecosystem is MLflow model registry. When you have success experiment run, you have artifacts which produced by this run. You can define this artifact as a model and assign a particular version to it. As example, you train the neural network, you have saved weights, the TensorFlow model, as example. You can save this model and say that it will be my model version 1. Next time you're training the same model, you're changing architecture, you get better result. You're saying it's my model version 2. And you can operate between different versions, and more you can provide the staging where reflecting status for your model. Which version goes to production, which version is preparing for production, and which version is no longer needed and archived. All these instruments is open source. They work as a part of Databricks cluster, but they can be deployed separately and used separately. The second technology that we will be discussing will be Kubeflow pipelines. Kubeflow pipelines is an application that you install on your Kubernetes cluster built on the top of Argo workflow. It helps you to create a direct acyclic graph of different substeps which run one by one if previous step is succeed. And because these all steps can be run independently, you can parallelize execution for your pipeline and make speed up out of the box. The biggest important step inside this graph is that you can allocate resources on demand. And it's a big comparison, big difference between running code on Kubeflow pipelines and running code in your Jupyter notebook is that when you spin up Jupyter notebook, it's always allocates resources. It's always billing you. When you have Kubeflow pipelines, you run code only when it's needed. And if you need to use expensive GPU, it will be allocated only for the part which is really required. As example, on this picture, we have only 2 steps out of the whole pipeline which actually require training for GPU. And we allocate GPU only for execution these nodes. Right after, and this node is no longer running, this GPU will shut down and save resources in our company, in your company. That maybe sounds not so important, but when you have a big data science team and they're working on multiple deep learning projects, the cost for GPU can be skyrocket. And this help you to share resources and allocate it only when it's needed. It saves a lot of money. Each step inside this pipeline is actually running small Docker container, which contains code for this exact step. It can be created separately, or it can be created programmatically right from your Jupyter notebook or from your GitHub project. All these containers can be created when you have your pipeline set up. Let's try to describe the common model development process, how it can be achieved using these components. Your data science team is starting to create the project. They commit their changes into GitHub, and our Jenkins server see that GitHub was changed. It pulled the latest changes. It's going through the pipeline and it's create all necessary Docker containers, and it's uploading pipeline into Kubernetes cluster. So from this moment, you have your pipeline working, and you have your containers updated. And you can have your data science team go to Kubeflow pipelines UI and run experiments. So after your Jenkins updated the pipeline, all lesson code and all containers up to date and ready for run. So data science team can choose parameters for particular experiment and run training. The training will be executed on Kubernetes, but from the code, you can call MLflow for tracking all metrics, parameters, and artifacts. It's fully on data science team responsibility. It's not happening automatically. So you need to ask them to log experiments. But all this infrastructure can be prepared for them. So you can give them template how to do that. Say you need to track inside this MLflow tracking server, and they will save all their models into this model registry. After we have our model in model registry and we're ready to move one of these models into QA environment, or after we finished QA testing, we can do following. Inside the model registry, we have things called stages. There are 3 different stages that data science can change. And here it's a staging state. It's preparation for QA. So when you see that your model is getting good metrics, you're sending it to QA. QA team validated and saying that this model is very good, we can proceed with production. So next, data science or team member who have proper rights, if you have rights restricted access, they promote this model from staging to production. Jenkins can receive this signal using custom plugin that we wrote, or by pulling model registry from time to time, see for the last changes. As soon as it's getting a signal from the MLflow server, it's receive all information about model, and we know that this model is tied with GitHub, tied with artifact, tied with all proper parameters. So we can grab this all information from MLflow tracking server and wrap this model with proper serving part. When we're saying proper serving part, you have different frameworks. Because you have different frameworks, you have different way how you can serve these models. For TensorFlow, the most suitable way will be using TensorFlow serving, and you just wrap your model with TensorFlow serving container and deploy it. For PyTorch, you have different options. You can have torch serving, you can have Seldon, you can have Flask-based application which serving this model, and the type of the model that is saved is also stored in the model registry. So Jenkins can automatically define which model type you have and choose the proper serving options automatically without any people involved. So you don't need to ask your data scientist to create the actual server and to deploy it, because everything is standardized and they can be pulled away from this process and focus on the actual work, which is the model training and the model tuning. And that it can up, of course. After this proper serving unit is chosen, you can deploy it as a service into Kubernetes using Spinnaker or using custom script deployments. And this service can be tracked by monitoring. You can use Prometheus for that and custom plugins into BigQuery. So in generalize what we just spoke about, the key component of efficiency is to separate data scientists from DevOps team. When you ask data scientists to do DevOps or do engineering, in most cases they hesitate. They ask for help, or they're doing it pretty slowly because it's not their primary work, and that's okay. They have a lot of specialized knowledge, which is part of this profession. And you can have your team of DevOps working on this separately and helping them only for deployment part with minimal impact. We combine Jenkins, Kubeflow, MLflow, and building full cycle of ML deployment when all people know their place and they have a standards which they can follow. MLflow in this process is kind of optional because you can store the Kubeflow artifacts. You can store artifacts inside the Kubeflow system itself, but it's providing the useful component which help you to make this process more efficient. Next step after this tech talk. So we will be presenting blog posts in our blog blogs. Check this out. And I was mentioning our custom plugin that help you to integrate your MLflow model registry and CI/CD, which is Jenkins. When we're talking about Databricks solution, they have this as a part of their platform. You can choose the staging and it will automatically be deployed inside the Databricks cluster. But if you don't have Databricks cluster and you have only open source tools on some kind of Kubernetes solution, you need to create this integration by yourself. We already did this, so we will be open sourcing this plugin. stay in touch, and I will be glad to answer any of your questions.